Okay, so I almost started this problem without actually figuring out what we need to solve for. And this time I'm not going to do all the color coding for what we need to solve for. I'm not going to color code everything. I did that in the last video and that took forever. But I am going to try to make everything pretty clear. Oh, right, and let me go here. We're going to label this point A, this point B, this point C, whoops, C, D, and E. Okay. And this we'll name this ground. Instead of ground, let's call it R. Whoops, I should probably make that like brownish or something, white maybe. Yeah, let's make it R. Okay. So we're gonna say that's like rotting animals, right? Rotting animals in the ground. Okay, so that line is R. So what are all the different things that are touching? Okay, well let's see. We've got A is touching B. A is touching C. Whoops. A is touching D. A is touching E. A is touching a lot of things. So just a notice, since it's connected in so many ways, this is probably going to be one of the last joints that we look at actually, but we'll get to that eventually. AE. What else? Let's see, we're going to B. B is touching A, but we've already got that taken care of. B is not touching E. I just want to make that clear. B is not attached to E in any way. But B is attached to R, the ground. So we're going to actually write that RB. Because the real reason I'm doing that is because this is a reactant force. We can also think of it as the, whoops, what's that? That's the force that B and the ground are exerting on each other. So that's RB, rhythm and blues. Okay, C is touching A, but we already have that. So C is touching D, CD. What is D? D is touching C, we've got that. D is touching A, we've got that. D is touching E, so DE, digital electronics. And then E, we've already got all the rest of these. We already have A, E, and DE. So all that's left is RE, right? The reactant force on E. And actually what I'm going to do is I'm going to go back to using that ground term. So here, let me get rid of that. I'm going to go back to calling it the ground, because I actually think that that's better. Because you figure this is kind of like the ground or the wall. And then think about it this way. If you are pushing on a bench, and the bench is anchored into the ground here, if you're pushing on a bench this way, or say you're pushing on the bench up here, or pulling back on it, turn your whole head to the left, 90 degrees, say this is like some kind of weird bench or something, and you're pulling on it, well then, these places where it's anchored into the ground have got to kind of pull back, or push back. So there's going to be one more force, or actually two more forces, because there's two anchors here, that we have to look at, and those are RB and RE. And basically what each of those are is that's how much it's any fixed pin thing here, anything that's screwed into the ground, nailed into the ground, whatever, it's basically how much sideways force it has to be able to withhold. So that way, if basically this is that way I can't push over the house and it doesn't just slide, or these don't just break if I just push, right? Because you figure it's attached to the ground, so it can pull and push off the ground, but it also needs to have something kind of like stabilizing it right here, or something holding it in strong enough, so that way it doesn't just push back and forth kind of thing. I hope that makes sense. I'm not sure if it does, but I mean, maybe the best thing I could think of is, say this is a shelf. If you have a weight sitting up top here, if this is a shelf, well then each of these pins are going, or screws rather, are going to be pushing downwards into there, so you just have to have some sort of lateral force in that direction. So I'm putting RB and RE over here as well. So these are all the things we need to solve for. God, that's overwhelming. In fact, I think what I'm just going to do is I'm going to set up the problem, and actually I'm going to actually start the problem in the next video, now that I've got this all set up. Again, I said this looks overwhelming. It's really not that bad, which you'll see. It's more of the same stuff we've been doing, and then at the very end, I'm going to teach you a bit of torque truss analysis. Doesn't that sound fun? No, it doesn't. But I will. I'm right about to make the next video, so I'll see you then.